Uh, so I think probably the best plan of attack is let's just start going through some problems and see how much you actually ingested yesterday, how much you digested. So assignment number 45. And why don't we just go ahead and start with problem number 1? So I'm going to be asking you a lot of questions today, and it's helpful if you answer them. Even if your answers are wrong, answers are just always appreciated. Do you remember from yesterday what this is called? Nailed it.
Special.
It is one of the special cases. It is specifically, that's right, Serenity. This one specifically is called a difference of squares. You can say difference of two squares, or you can just difference of squares. The thing about assignment 45 today is that everything on this paper is either a difference of squares or the other one, a square trinomial. The assignment tomorrow is going to be more difficult because it's going to be a mixture of all the stuff we've talked about. So you can't rest assured that they're all going to be a certain thing. But today you can. So just enjoy the fact that if it looks like a difference of squares today, it is. And for the people, the one person that was gone and maybe anybody else, what was the dead giveaway to make me think this is a difference of squares? There's no middle term. Right. That middle term, the one in the middle that would just have a regular b, like a plus 5b or something like that, it's not there. So as soon as we recognize and it passes the three, does anyone remember the 3-step test that we give it to see if it's a difference of squares? What's step 1 is to check in the middle, is that a minus? And if it passes that test, then we go moving on. Test 2 is, are they both squares? And so if you don't know what that means, it is your job to ask, since I can't read minds. Is that a square? Yes, it is, because the square root of it is nice, right? So something is a square if it's square rootable. There's a little more to that definition, but that'll work. And then is this a square? It is. 9 is a square because its square root is 3. And so we're going to proceed with this one to do 1 shell or 2 shells. 2 shells for this kind, because the difference of squares requires, remember, to make the magic happen, we need a cancel. And the only way to make a cancel is to have a plus and a minus. You could never achieve a cancel with 2 pluses or 2 minuses. And then I'm trying to model for you certain behaviors, and like the way I'm circling things and writing things down is going to help you a lot. So I wrote down the little red thing up there and I wrote down the little yellow thing up there, and I don't have to do any more math at all. All I have to do is put red thing here, red thing here, yellow thing here, yellow thing here. And that's how easy it is to factor a difference of 2 squares. Okay, but again, you have to do your due diligence and make sure doing the 3-step test that it actually is a difference of squares. So because there will be times in the future where something looks like it might be, but don't assume just because it like has a minus and it's short. It's irresponsible. All right, how about question number 2? It says n squared plus 6n. Huh? Say it again. This one is the other flavor that we learned yesterday. This one's called a square trinomial. And there's a trick to this too. But the first thing, and I'll show you an example in a few minutes of when it's dangerous to assume that because something kind of looks like a square that it is. This one is because it's on assignment 45, and I told you that they all would be. But the test goes as follows. Test 1, is that a square? What's its square root? So I like to write that down. Is yellow thing a square? What's its square root? I like to write that down. Now, there's a little bit more to this than the difference of 2 squares. There's a way to verify that it's actually a square trinomial. You multiply them and then you double. So basically what you want to do at this point is put blinders on and not look at the middle of the problem, because you don't want to sway yourself. You don't want to bias your calculation. So if I take my red thing and my yellow thing and I multiply them together, what do I get? I get 3n. That's just red times yellow. And if I double that, I get 6n. And all I need is in the middle for there to be a plus 6n or a minus 6n. As long as it's some flavor of a 6n, then we're in like Flynn. And then I look and go, jackpot. So to factor this one, do I need,
How how would it work without the names again?
it will only affect the ending. And ask that, if you have that question in 30 seconds, ask again. Okay? But I should answer it here in a moment.
Yeah.
How many shells do we need for this type? Just one. Because remember, the factoring of this is going to come out to be the same thing in both. So we've learned that we can just bypass it with a square. So we're just going to put one set of parentheses with a square. It really, again, it's just like airmail. Like we're just going to drop stuff in. I mean, step one is take the red thing and just airmail it. Boop, drop it right there. Plop. Take the yellow thing, drop it right there. And then Colton, to your question, um, this sign that I'm circling in green will get copied basically into our square factor.
Unless it's named.
If it was a minus, then I would put a minus here, but since it's a plus, I'll put a plus here. Got it? These, the two with the big purple things around them, those ones are always going to be pluses. Like they have to be for something to be a square. It's the one in the middle that's going to waffle back and forth, and whatever it is, then we take it down with us. Yep. Anyone have any questions so far? Let's keep going for, I feel like we should do a couple more and then I'm going to jump down a ways. Because I think it's good that we keep vibing together here on this. Number 3 is 4 variables squared minus 25. What's this one? Difference of two squares. So, I mean, yeah, it passes all 3 of the tests. Test 1 is that a minus? And the answer is yes. Remember, if that's a plus, then we're going to go elsewhere. There will be times when it's just not factorable at all. There will be times when maybe there's a plan B. But if we're talking in the context of the like the plus and minus square pattern, plus there is fatal, like it's over. So test 1 has been passed. Test 2 is this. Is that a square? I keep asking this question, and if you're sitting here anonymously waiting for it to happen, like you need to advocate for yourself and speak up. A square is something that is square rootable without stress, no decimals or anything. What is the square root of what I circled in red? It is 2p. Is this a square? What is its square root? 5. If it passes all 3 of those tests, it's a difference, and you got a square and a square, your green light, go. So how many shells do I need for this one? 2. It's a difference of squares, so this is going to be a simple opposite pattern. One of them is going to be a plus and one of them is going to be a minus because we're forcing there to not be a p term in the middle. I doubt you've made it this far through yesterday and today without understanding that, but all of what we're talking about right now is based on the fact that there's a term not there, right? We all see that? It's where this really fat green arrow is pointing. Like right there, there would normally be like a plus 5p or a minus 11p. The fact that that's not there is why we talk about this. So now it's just a matter of drop stuff in. In the front of each shell goes your red thing. In the back of each shell goes your yellow thing. And someone, I knew I'd kind of failed in one of the classes when someone earlier said, bring down the sign. And I was like, oh crap. Okay, we're getting our signals crossed. This isn't like that. That's when we do square trinomials. This one is always just one of each. Right. 1 plus 1 minus. Put them in any order you want, but for God's sake, there's no like bringing anything down at this point. That's it. Someone asked earlier, so would it be okay if I wrote it and I cut them off and said, if you're going to say exponent, God, no. Of course it's not okay because these are not the same, right? So that's it. That's what you get. Question 4 is our first chance to talk about something else. And I think after we'll do like 4 and 5, and then I'm going to jump down and pick a couple randos. But 4 is this. And I really tried hard yesterday to get this across to you, but I know that it's going to be something that it's a fight or an endeavor that I have to endure for a while. What do we do? This. I I cannot stress to you enough how this will make or break virtually almost everything we do in math from this point on, not just even this year. But when you're looking at something, you need to always look at its factors and ask yourself, and I regret that it hasn't been an issue. I wish I would have, if I had this worksheet to make again, I probably would have stuck a GCF forcefully into like problems 1 or 2, but I didn't. But in question 4, it's our first opportunity to blow it. Don't blow it. What do you notice about all 3 of these terms? Yes. And if you don't pull that out, sometimes you can honestly fudge your way through a problem and save it at the end. But a lot of times you're never going to get to where we want you to get if you don't see the GCF. So the first thing we're going to do is we're going to take a 3 and we're going to anti-distribute it from all 3 terms, right? So we take the 3 out front and then we rebuild the polynomial. What's the first term? Just regular x squared now because we took away his 3. What's the second term? Plus 2x because we divided him by 3. And what's the last one? Plus 1. And because this is a polynomial on assignment 45, we would, of course, conjecture at this point that it's probably going to be a square trinomial. Let's do our due diligence and just verify this. The 3-step process, it's more of a 4-steppy almost, but to test if something is a square, you go like this. See the red thing? Is it a square? What's its square root? We write it down. See this yellow thing? Is it a square? Yes. What's its square root? 1. The square root of 1 is 1. Since I have those numbers up there, I can talk to you in plain English. Take the red thing and the yellow thing and multiply them together. What do you get? You get 1x. Double that. What do you get? If we did 1,000 of these together, my explanation isn't going to suddenly change. The steps I do aren't ever going to change. It's a very repetitive square root goes here, multiply, double, check. And then I look in the middle and I ask myself, is there a 2x? And I go, there is. That means this is a square. So the answer is going to be GCF single shell squared. And what do we drop into the single shell? X, 1, and then mimic the plus down. Good job. Square trinomials factor like that. Question 5. Don't worry, I'm going to save a bunch of these for you. I know you don't want to do them all together. Question 5. What? What's question 5? Is it a difference of squares? I'm going to ask you this again, and I know you probably think I'm being weird, but is number 5 a difference of 2 squares? It is not. But your heart's in the right place if you say yes, because there is one in there, right? In its current state, it is not a difference of 2 squares. What do we have to do first? Yeah, and if you do not answer this question this way, you and I are just always going to be at odds. The answer always to what do we do first? And when I say always, I don't take that word lightly. The answer always is look for a GCF. That is not an insinuation that there's always going to be one. But if it's not your first thought to check, half the problems you're not going to ever be able to do. So is it a difference of squares? No, but we're going to make one. We're going to find one. We're going to rush the dirt off the surface and find it. And that dirt on the surface is the number 2, because both of these numbers that I'm underlining can be divided by 2. So if I take the 2 and I pull it out, I'm left with x squared minus 18 divided by 2 is 9. Then we're able now, if we have the 2 sort of in timeout, and we can then answer the question correctly, is the thing I'm underlining a difference of 2 squares? Now it is. It is, right? And it's a plus and minus pattern. Remember that the difference of two squares is not a single shell squared. It wouldn't ever make sense to do that. You are lost if you don't understand why that is. And I'll talk you through that. This has to be the plus or minus pattern. It's the only way to make the zero in the middle. So GCF gets copied, two shells, one gets a plus, one gets a minus. It's the only way this can work. What's the square root of x squared? X. So you put that here and you put that here. What's the square root of 9? So you put that here and you put that here. And then you put a big old celebratory box around this. And that's that. So I'm going to skip down a little ways to something like question 14. And if any others catch your eye, we can do them. And then after 14, I'm just going to, what's the matter?
Just looking at the numbers.
Oh yeah, it can be a little intimidating. After 14, I'm going to show you an example if I can find there it is, my note card. I had one problem I wanted to show you, and it more is for tomorrow, but I wanted to kind of get it in your head. So anyways, question 14 is scary as all get out.
I think it might be,
19 is scary in the same way that 14 is scary. And in a perfect world, I would only have had to say this once or twice, but I will wind up bringing this up probably in the neighborhood of like 75 or 80 times. If you're tired of me asking this question, then eventually you all have to shout the answer to me at the exact same time in under a half of a second. What is step one? GCF. If that was not your first thought, then I'm still failing you. If your first thought had anything to do with check if it's a square or this, I continue to fail you. Step one, without any negotiation, is to look at the numerical parts, this, and this, and ask yourself, can I divide them all by the same thing? And the answer is, I can. Someone wants you to do that. What is the biggest number that they can all be divided by? Certainly 10 wouldn't work because of the 4 at the end of the 64. 4 is our guy. Someone earlier said 2, and it's like 2 works, but if you do 2, then you got to go another round. And it's like, go big or go home. Between you and a calculator in about 20 seconds, you would eventually figure out that all 3 of these numbers can be divided by 4. And when you see the result, you'll see that would have been the best we can do. GCF. I'm going to take 4 and I'm going to undistribute it from all 3 terms, putting it right there. And then I'm going to rebuild the problem. What does 100x squared drop down to? 25. What does 160x drop down to? 40. That would be if you divided by 5. If you pulled 160 divided by 5, that'd be 32. It's cool that you have that knowledge up there. It was just kind of the wrong connection there, but pretty sweet. And then what's 64 divided by 4? 16. You can tell that you did well when you can look at all the numbers that are left and they can no longer be divided by anything. If you had pulled out a 2, these numbers would have been 50, 80, and 32. And as a high school student, it would be your responsibility to identify that, oh, I could have done more because those can all be divided again. So that's why we use the 4. Are we ready to press on? Now, what's the next step? Run it through the test. Is that a square? What's its square root? Not 5. 5x. Is this a square? What's its square root? Next thing we do is what? We multiply the red and the yellow together because we're still in checking mode. I still want to know if I can do the shortcut cheat. What do they call that? Cheese in a video game. Like if you can find an easy way to beat a boss, they call it cheesing the boss. You guys all know that stuff. So if we want to see, let's see if we can cheese this problem. Ready? What's yellow times red? 20x. Double that. What do you get? Is 40x in the middle? Then it's a cheese. You can cheese it. You don't have to do any math at this point. You're like a robot. Bring down the GCF, bring down one bracket, stick a square on it. What drops into the first slot? 5x, red guy. What drops into the second slot? 4, the yellow guy. And what sign goes in the middle? Plus. And we know it's a plus because the one up here in the middle of the OG problem was a plus. So tomorrow I'm going to give you a harder assignment called mixed bag. And I called it that because for the first time ever, it's going to have a little sampler platter of everything. And I wanted to show you this problem. And then I swear after this, I'm going to shut up. The only other time I'm going to be talking to you after this is when, or if you have questions you want to go over. What do you guys think this is? Do you think it's a difference of squares or a square trinomial? It's not a difference of squares. So you think it's a square? If you don't know what I'm talking about, then maybe I'm talking to the wrong class. But listen, here's what I find is the case. A lot of times, kids that 80% listen, because your brains are in and then they go out a little bit, and then they come back in and then they go out. It's very easy to look at this and say, wait, this is one of those square trinomials. Let's run it through the test. Is that a square? What's its square root? Thank you for adding the x. Is this a square? What's its square root?
3.
Multiply those together. What do you get? 6x. Double that. What do you get? Is there a 12x in the middle? So I want to make sure that you understand heading into tomorrow that that does not mean we write something like IDK LOL. I don't think this can be factored or no solution. This problem very much is doable. Very much. It's just not doable in the assignment 45 way. This takes us back to assignment 44, 43, when we roll up our sleeves and we go back to the drawing board and we go back to this. Do you remember this? You should, since it was just a couple days ago. You can't cheese this boss battle. That little algorithm we did where we did the square root and the square root and we multiplied and doubled and went, it doesn't match. It doesn't mean the problem's not possible. It just means you can't cheese it. So I'm going to not waste your time, but trust me on this one. You'd go through the normal stuff and you'd say, okay, the guy in the back is a plus, the guy in the, okay, so that means I got to have 2 minuses. And then eventually you're going to figure out big brain mode that if you put a 9 right here and a 1 right here, guess what? It works. It just doesn't work in the cheese way. That's going to be a very important conversation going forward. Just because it's not a square doesn't mean it's like can't do or no solution or whatever. It just means you got to go back to what you knew before. Assignment 45 is all about shortcuts. So at this point, I'm going to pause this and shut up, and I'm going to let you guys work for the last 20 whatever minutes. And if you have questions, if someone says, hey, can we go over this or this, I'll unpause the recording and just stick it on there, whatever I can do for you. Got it? And I did put the answer key for this up on Canvas, so it's there. So you can either do a couple, check as you go, or you can do the whole thing and check later. Why are you looking at me like that?
I was wondering what
I'm going to leave this on the recording. Everybody look at question number 6, because I'm sure that that's where you're at, right? So what do you think number 6 is? I mean, I know this young man right here is going to learn something from the following conversation, but I need to make sure that you all learn. The fact that I just got asked the question of what's the square root of 125 means that I have failed again to get my point across. What is the first thing we do 100% of the time? What? 100% of the time we look for a common factor. And when we look at problem number 6, if you jump right in and your first question is what's the square root of 125, I failed you. You're not hearing me. You're not listening. You're putting up a wall and you're blocking me, and I'm going to break it down. What can these both be divided by?
5.
And if you do that, then you will no longer have the question of, I wonder what is the square root of 125. It will never be a concern, because if you pull the 5 out like you're supposed to, what does the 5n squared drop down to? N squared. And what does the minus 125 drop down to? If you have a $1.25 and you make it with 5 coins, What is the value of each coin? 25 cents. And now the question isn't what's the square root of 125? It should never have been the question in the first place. Because if we pulled out the GCF, then it reveals itself as a difference of two squares. And now we're smooth sailing. What's the square root of n squared? What's the square root of 25?
Yeah.
And now it just floods right into the plus or minus pattern. Game over. The simplicity happens when you pull out the GCF. Need one of those Vegas flashing signs that says GCF. Just put it right above my desk there.